In the last 72 hours, our understanding of what moves through space has fundamentally changed. When 3I Atlas reached its closest point to the Sun, something unprecedented occurred. Instead of burning away like every comet before it, this interstellar visitor did the impossible. It absorbed solar material and emerged transformed. Multiple observatories detected the same impossible sequence. A brief surge of radiation as the object approached perihelion, followed by complete silence. Then, when 3I Atlas reappeared from behind the Sun's glare, every instrument showed the same shocking result. The object had become denser, darker, and was radiating energy in ways that defied everything we know about celestial mechanics. Tonight, we examine the data that's left scientists questioning whether we're witnessing natural physics or something else entirely. Because what happened near the Sun wasn't destruction, it was absorption on a cosmic scale. If mysteries like this capture your imagination the way they do mine, make sure to hit that subscribe button right now. Drop a comment letting me know where you're watching from and whether you think we're seeing the full picture of what's really happening out there. Let's start with what should have happened. When any object approaches the Sun at the distance 3I Atlas travelled, the physics are straightforward and brutal. Solar radiation should strip away surface material through a process called sublimation. The intense heat vaporizes ice and volatiles, creating the familiar glowing tail we associate with comets. For rocky objects, thermal stress causes fracturing and gradual erosion. Either way, the result is mass loss and eventual disintegration. 3I Atlas did none of this. Instead, observations from the Solar and Heliospheric Observatory showed something that shouldn't exist in nature. The object's spectral signature vanished completely for several hours during perihelion. Not because it was destroyed, but because it was changing at a fundamental level. When it emerged from behind the Sun, spectrographic analysis revealed a surface that no longer matched its previous composition. The metallic traces that had defined its earlier spectrum were now dominated by heavier elements. Nickel and iron signatures had intensified dramatically, while new absorption lines appeared that couldn't be immediately classified. The most disturbing detail came from the brightness measurements. 3I Atlas had become significantly darker, absorbing nearly 95% of incoming light instead of reflecting it. This wasn't dust coating from solar debris. The readings indicated a fundamental change in surface properties, as if the outer layer had been completely restructured. NASA's Jet Propulsion Laboratory ran the numbers multiple times, each calculation confirming what seemed impossible. The object's density had increased by approximately 8% without any corresponding change in volume. In simple terms, 3I Atlas had somehow become heavier while maintaining its exact same size. Dr. Sarah Chen from the European Southern Observatory described the phenomenon during an internal briefing as absorption without expansion. Her team's models showed that for this to occur naturally, the object would need internal voids that collapsed under pressure, sealing themselves in the process. But the precision of the density increase across the entire body suggested coordination that random collapse couldn't achieve. The Parker Solar Probe, positioned closer to the Sun than any human-made instrument, captured the most detailed view of what actually happened during those crucial hours. Its plasma sensors detected a localized depletion in the solar wind immediately around 3I Atlas. For approximately 40 seconds, a measurable amount of charged particles simply vanished from the surrounding space. This wasn't scattering or deflection. The readings showed an actual reduction in plasma density, as if the material had been drawn inward and absorbed into the object itself. The phenomenon created what researchers are now calling a plasma void, a temporary bubble of reduced particle density that followed the object's path through the solar corona. Simultaneously, the stereo spacecraft array recorded something even more extraordinary. A faint arc of plasma appeared to connect 3I Atlas directly to the Sun's outer atmosphere. For nearly 6 minutes, this luminous filament persisted, fluctuating in brightness before gradually fading. The imagery resembled a magnetic tether, channeling material from the solar corona directly to the interstellar visitor. When scientists enhanced the footage and played it in slow motion, the implications became clear. 3I Atlas wasn't being bombarded by solar radiation. It was actively drawing energy and material from the Sun itself. The thermal data tells an equally puzzling story. Instead of the rapid temperature spike expected during close solar approach, instruments detected a controlled rise occurring in 3 distinct phases. Each phase plateaued before progressing to the next level, creating a stepped pattern that resembled engineered heat management rather than natural thermal absorption. This pattern continued even after perihelion. While the object should have been radiating excess heat back into space, infrared sensors showed it maintaining a steady temperature well above what solar distance alone could explain. The heat wasn't escaping. It was being retained and redistributed through internal mechanisms that shouldn't exist in a natural body. Ground-based observatories tracking the object's post-perihelion trajectory discovered another anomaly. 3I Atlas had slowed slightly, its orbital velocity decreasing in a way that suggested internal mass redistribution. The change was minimal but measurable, indicating that whatever absorption process had occurred was still affecting the object's physical properties. More concerning was the radar silence. When multiple facilities attempted to map the object's internal structure using radio waves, they encountered something unprecedented. Instead of the scattered returns expected from any solid body, 3I Atlas absorbed the radar signals completely. No internal echoes, no structural variations, just perfect absorption across all frequencies tested. This acoustic silence extended to other wavelengths. Attempts at deep scanning using various forms of electromagnetic radiation all produced the same result. The signals entered the object and simply disappeared, as if being absorbed by material specifically designed to prevent detection. The magnetic readings added another layer to the mystery. During its closest approach to the Sun, 3I Atlas briefly generated its own magnetic field, strong enough to deflect high-energy particles and create a protective envelope around itself. This field appeared and collapsed in rhythmic cycles, each pulse coinciding with increased plasma absorption from the surrounding solar wind. For a natural object to spontaneously generate organized magnetic fields requires specific conditions that simply don't exist in typical interstellar debris. The field patterns observed suggested either exotic materials reacting to solar radiation or active systems designed to manage electromagnetic environments. What makes this even more perplexing is the timing. The magnetic envelope activated precisely when solar particle density reached dangerous levels, almost as if the object was responding to environmental threats. When conditions stabilized, the field collapsed back to normal levels with mathematical precision. Teams at the Very Large Telescope in Chile have been conducting follow-up observations, tracking 3I Atlas as it moves away from the Sun. Their findings confirm that whatever transformation occurred during perihelion appears to be permanent. The object continues to emit infrared radiation at levels inconsistent with passive cooling, suggesting internal energy sources remain active. The spectral analysis reveals ongoing chemical activity on the surface. Molecular bonds are still forming and reforming weeks after the solar encounter, indicating that absorbed plasma continues to interact with the object's structure. This isn't the behavior of inert rock cooling down after heat exposure. It resembles active processing of incorporated material. Perhaps most unsettling is the discovery of geometric patterns in the surface emissions. When viewed through polarized filters, 3I Atlas shows regular repeating structures in its thermal output. These patterns maintain perfect symmetry and appear at precise intervals across the object's surface, suggesting organization at a molecular level that natural processes rarely achieve. The energy retention capabilities demonstrate another impossible characteristic. Natural bodies radiate absorbed heat according to well-understood physical laws. 3I Atlas seems to be storing energy internally, releasing it in controlled amounts over extended periods. This behavior resembles engineered heat management systems more than geological processes. Current models suggest the object may have developed or revealed a layered internal structure during its solar encounter. Different density zones appear to be managing energy flow, creating the stable temperature profile observed in ongoing measurements. Each layer seems optimized for specific functions, whether energy storage, thermal regulation, or structural integrity. What we're witnessing challenges fundamental assumptions about how matter behaves under extreme conditions. The precision of 3I Atlas's responses to solar radiation suggests either unknown physical processes or mechanisms designed to exploit those processes for specific purposes. The implications extend far beyond a single unusual object. If natural processes can produce structures this sophisticated, we need to reconsider what's possible in cosmic evolution. If these aren't natural processes, we're confronting evidence of engineering on an interstellar scale. As 3i Atlas continues its outbound journey, carrying within it the absorbed essence of our Sun, one question dominates every discussion among researchers. Are we observing the most exotic natural phenomenon ever recorded, or have we just witnessed technology in action? The data continues streaming in from observatories worldwide, each measurement adding another piece to a puzzle that grows more complex with every answer we find. The electromagnetic signatures tell a story that defies conventional understanding. As 3i Atlas moved beyond the Sun's immediate influence, observatories detected something that shouldn't exist in nature. A plasma halo began forming around the object, glowing with an intensity that had nothing to do with reflected sunlight. This wasn't the diffuse glow typical of cometary activity. The plasma envelope maintained perfect symmetry, rotating in lockstep with the object's spin while exhibiting structural coherence that natural gas clouds simply cannot achieve. The halo pulsed in regular intervals, cycling from brilliant white to deep violet in synchronized waves that responded to solar wind fluctuations with impossible precision. What makes this phenomenon truly extraordinary is its persistence. Plasma structures typically dissipate within minutes once they lose their energy source. The envelope surrounding 3i Atlas has maintained its form for weeks, drawing power from internal reserves that continue to mystify researchers. The Parker Solar Probe's instruments recorded the formation process in real time. As 3i Atlas absorbed solar material during perihelion, excess plasma didn't simply disperse into space. Instead, it organized itself into this rotating shell, held in place by magnetic forces emanating from within the object itself. Dr. Martinez from the European Space Agency described the phenomenon as controlled plasma confinement, noting that the magnetic field strength required to maintain such a structure would need to originate from sophisticated internal mechanisms. Natural magnetism in rocky bodies operates at completely different scales and lacks the dynamic control observed here. The halo exhibits another disturbing characteristic. It responds to external stimuli with reaction times that suggest active monitoring systems. When solar flares increase radiation pressure, the plasma envelope adjusts its density and rotation speed within seconds. This adaptive behavior indicates either unknown physics or deliberate engineering designed to maintain optimal conditions. Spectroscopic analysis of the plasma itself reveals a composition that matches the solar material absorbed during perihelion. Excited hydrogen and oxygen ions cycle through the envelope in patterns that suggest they're being processed rather than simply contained. The wavelength signatures indicate internal excitation sources continuing to energize the captured plasma long after its initial absorption. Ground-based observatories have identified rhythmic variations in the halo's intensity that occur every 3.9 minutes with clockwork precision. This regularity points to internal timing mechanisms that control energy distribution throughout the plasma shell. Natural phenomena don't maintain such mathematical consistency over extended periods. The thermal behavior of 3i Atlas itself has become even more anomalous as it moves away from the Sun. Rather than cooling in accordance with distance and time, the object maintains a steady temperature that suggests active heat generation. Infrared measurements show hotspots migrating across its surface in predetermined patterns that repeat every 90 minutes. These thermal migrations don't follow solar illumination or random convection. They trace precise paths as if following internal conduits, designed to distribute heat evenly across the object's structure. The symmetry and timing indicate sophisticated thermal management systems operating continuously. More disturbing is the discovery that 3i Atlas appears to be recycling its thermal energy. Each time it radiates heat into space, sensors detect a corresponding absorption of background infrared radiation from the surrounding environment. The object seems to be maintaining energy balance by drawing in ambient heat to replace what it loses through radiation. This energy conservation behavior resembles the operation of engineered systems designed for long-term stability in harsh environments. Natural bodies don't exhibit such precise energy management, especially not across the temperature differentials encountered in interplanetary space. Radio telescopes, monitoring the object, have detected faint electromagnetic emissions synchronized with the thermal cycles. These aren't random bursts, but structured signals occurring at frequencies associated with hydrogen spin transitions, wavelengths commonly referenced in theoretical plasma propulsion concepts. The signals appear to be byproducts of whatever internal processes are managing the absorbed solar material. Each emission coincides with minor fluctuations in the plasma halo's intensity, suggesting coordinated activity between the object's core systems and its external envelope. NASA's Deep Space Network has catalogued these transmissions as residual electromagnetic coupling, but the precision of their timing raises questions about whether they represent intentional signaling or merely operational noise from active systems. What makes these emissions particularly intriguing is their consistency across multiple monitoring stations. The signals maintain identical characteristics regardless of Earth's position relative to 3I Atlas, indicating that they originate from stable internal processes rather than environmental interactions. The object's trajectory has also revealed subtle but significant changes. Instead of following the predicted hyperbolic path out of the solar system, 3I Atlas has made minor course corrections that suggest active navigation. The adjustments are minimal but consistent, occurring at regular intervals that coincide with the electromagnetic emission cycles. These trajectory modifications don't result from gravitational influences or solar radiation pressure. The velocity changes are too precise and too well timed to represent random forces. They indicate controlled thrust applications using energy sources internal to the object. Gravitational modelling confirms that 3I Atlas is now more massive than when it entered the solar system, but this increased mass is distributed with perfect uniformity. The object maintains ideal rotational stability despite its density changes, suggesting internal mass redistribution systems that actively maintain balance. The radar absorption capabilities have become even more pronounced since perihelion. Current attempts to map the object's internal structure encounter complete signal suppression across all tested frequencies. The absorption is so thorough that it resembles stealth technology designed to prevent detection rather than natural material properties. This electromagnetic silence extends to optical wavelengths as well. 3I Atlas now absorbs over 97% of visible light that strikes its surface, making it one of the darkest objects ever observed in the solar system. The absorption efficiency suggests surface modifications that optimize light capture for unknown purposes. Infrared imaging reveals that absorbed electromagnetic energy isn't simply converted to heat and radiated away. Instead, it appears to be channeled into the object's internal systems, contributing to the ongoing energy cycles that power its various active behaviors. The surface itself shows signs of continued evolution weeks after the solar encounter. Microscopic analysis through advanced telescopic systems reveals geometric patterns forming and reforming in regular cycles. These aren't random crack patterns from thermal stress, but organized structures that suggest molecular-level engineering. The patterns exhibit hexagonal symmetries that repeat at precise intervals across the visible surface. This level of organization requires coordination between surface elements that natural materials cannot achieve without external control mechanisms. Polarization measurements indicate that light scattered from 3I Atlas is being twisted in specific directions as it reflects. This circular polarization occurs only when electromagnetic radiation interacts with carefully structured surfaces, typically those designed for specific optical properties. The twisted light signatures change in rhythm with the object's thermal cycles, indicating that surface modifications continue in response to internal energy states. This dynamic surface behavior resembles adaptive materials that adjust their properties based on operational requirements. Temperature mapping shows that different regions of the object maintain distinct thermal signatures despite the overall stability. These variations suggest internal compartmentalization, with separate zones optimized for different functions within the overall system architecture. The implications of these observations extend far beyond 3I Atlas itself. If natural processes can produce such sophisticated behaviors, our understanding of cosmic evolution needs complete revision. The precision and coordination observed suggest either unknown physics operating at scales we've never encountered, or technology designed to function across interstellar distances. Current models attempting to explain these phenomena through natural mechanisms require assumptions about exotic materials and processes that exist only in theoretical frameworks. Every conventional explanation demands the existence of conditions or substances that have never been observed elsewhere in the universe. The alternative explanation, that 3I Atlas represents engineered technology, aligns perfectly with all observed behaviors but carries implications that challenge our fundamental assumptions about intelligence and its distribution throughout the cosmos. As the object continues its journey beyond Mars' orbit, carrying its absorbed solar energy and maintaining its impossible characteristics, the scientific community faces an unprecedented dilemma. The data demands conclusions that existing paradigms cannot accommodate. Whether 3I Atlas represents the most exotic natural phenomenon ever recorded, or evidence of technology operating on cosmic scales, its behavior has already transformed our understanding of what's possible in the universe. The absorption event near the Sun wasn't just an anomaly. It was a demonstration of capabilities that redefine the boundaries between natural and artificial, between random and intentional, between what we thought we knew and what we're now forced to consider. The mystery deepens with each passing day as 3I Atlas maintains its steady course outward, pulsing with absorbed starlight, carrying secrets that may reshape our place in the cosmos. In the cosmos. The gravitational anomalies detected in 3I Atlas's wake present perhaps the most compelling evidence yet that something fundamental has changed within this interstellar visitor. As the object moves through space, it leaves behind distortions in the fabric of space-time itself that shouldn't exist for a body of its apparent size and composition. Deep space tracking stations have measured these gravitational signatures with increasing precision, revealing patterns that challenge our understanding of how mass and energy interact on cosmic scales. The distortions follow the object's path like invisible footprints, persisting far longer than any natural gravitational effect should maintain coherence. What makes these readings particularly unsettling is their mathematical perfection. Gravitational waves from 3I Atlas propagate outward in precise geometric patterns, creating interference nodes at specific distances that suggest deliberate wave shaping rather than random mass movement. Natural objects simply don't generate gravitational signatures with this level of organization. The Laser Interferometer, Gravitational Wave Observatory, has detected these anomalies across multiple observation runs, confirming that the effects aren't instrumental artifacts. The wave patterns exhibit harmonic relationships that mirror the electromagnetic emissions recorded earlier, suggesting coordinated activity between gravitational and electromagnetic systems within the object. Dr. Reeves from the Gravitational Physics Consortium noted that the amplitude and frequency of these waves indicate mass distributions that shift in controlled patterns. For 3I Atlas to generate such effects, its internal structure would need to actively redistribute matter in response to external conditions or operational requirements. The timing of gravitational pulses correlates perfectly with the thermal cycling observed through infrared monitoring. Each time the object's temperature fluctuates, corresponding gravitational waves propagate outward with clockwork precision. This synchronization points to integrated systems managing multiple physical processes simultaneously. Even more remarkable is the discovery that these gravitational effects seem to interact constructively with local spacetime curvature. Rather than simply adding to existing gravitational fields, the waves from 3I Atlas appear to modify the geometry of space around nearby objects, creating regions of enhanced or diminished gravitational influence. This spacetime manipulation has practical consequences. Small asteroids and debris particles in the vicinity of 3I Atlas show trajectory modifications that can't be explained by the object's apparent mass alone. The gravitational field seems to extend far beyond what conventional physics would predict, reaching out to influence matter across unprecedented distances. The European Gravitational Observatory has documented cases where particles approach 3I Atlas along curved paths that spiral inward before being redirected outward along different trajectories. These interactions resemble gravitational slingshot maneuvers, but they occur without the massive central body typically required for such effects. Theoretical physicists studying these phenomena have proposed that 3I Atlas might be manipulating local gravitational constants through unknown mechanisms. If the object can alter the fundamental strength of gravity in its immediate vicinity, it would explain both the trajectory modifications and the persistent gravitational waves. This capability would represent technology operating at the level of fundamental forces, manipulating the basic parameters that govern how matter and energy interact. Such control over gravitational fields would enable propulsion systems of extraordinary efficiency, navigation through complex gravitational environments, and protection from cosmic hazards. The energy requirements for gravitational manipulation on this scale should be enormous, yet 3I Atlas shows no signs of energy depletion. Instead, its power output remains constant, suggesting either energy sources of incredible density or conversion processes that operate with near-perfect efficiency. Long-range monitoring has revealed that the object's gravitational signature changes subtly, but systematically as it moves through different regions of the solar system. When passing through areas of higher particle density, the gravitational waves intensify. In regions of space with lower matter concentrations, the effects diminish proportionally. This adaptive behavior indicates that 3I Atlas responds to its environment by adjusting its gravitational output to match local conditions. Such responsiveness requires sensory systems capable of analyzing spacetime geometry in real time and control mechanisms that can modify gravitational generation accordingly. The implications for our understanding of physics are staggering. If gravitational fields can be controlled and manipulated as precisely as electromagnetic fields, entire categories of technology become possible that we've never seriously considered. Propulsion without reaction mass, communication through gravitational waves, and manipulation of matter through controlled spacetime curvature. Current attempts to model these effects using known physics require the existence of exotic matter with negative mass density or energy states that violate conservation principles. Every conventional explanation demands physics beyond our current understanding or materials that exist only in theoretical frameworks. The alternative interpretation suggests that 3I Atlas incorporates gravitational control systems as sophisticated as its electromagnetic and thermal management capabilities. The precision and coordination observed across multiple physical domains point to integrated technology designed to operate in the challenging environment of interstellar space. Quantum field sensors deployed at various distances from the object have detected fluctuations in the vacuum energy density that coincide with gravitational wave emissions. These quantum effects suggest that 3I Atlas is interacting with the fundamental structure of spacetime itself, manipulating the underlying fields that give rise to gravitational phenomena. The vacuum fluctuations follow the same rhythmic patterns observed in electromagnetic and thermal cycles, confirming that gravitational control is integrated with the object's other active systems. This coordination across multiple physical domains indicates a level of technological sophistication that challenges our assumptions about what's possible in the universe. Particle accelerators on Earth have attempted to replicate the quantum field effects observed around 3I Atlas, but the energy requirements exceed our current capabilities by several orders of magnitude. The object appears to be generating and controlling these exotic effects with efficiency that suggests either unknown physics or technology far in advance of human capabilities. The gravitational lensing effects around 3I Atlas have become visible to optical telescopes as the object moves against the stellar background. Light from distant stars bends around the object in patterns that don't match its apparent mass, creating multiple images and brightness variations that indicate complex gravitational field geometries. These lensing effects shift and change in real time, demonstrating that the gravitational field around 3I Atlas is dynamic rather than static. The field seems to pulse and flow like liquid, creating temporary focusing effects that concentrate or disperse electromagnetic radiation passing through the region. Advanced computer modeling of these lensing patterns reveals gravitational field structures that resemble engineered optical systems. The field geometries appear optimized for specific functions, whether focusing incoming radiation, deflecting potentially harmful particles, or creating communication channels through controlled spacetime curvature. The precision required to maintain such complex gravitational field patterns while moving through space at high velocity suggests computational systems of extraordinary capability operating within 3I Atlas. The object must continuously calculate and adjust its gravitational output to maintain optimal field configurations despite changing environmental conditions. Radio. Astronomy observations have detected gravitational wave echoes bouncing between 3I Atlas and nearby gravitational sources. These echoes create standing wave patterns in spacetime that persist for hours after the initial gravitational pulse, indicating that the object can create resonant gravitational structures that maintain coherence across vast distances. The standing wave patterns exhibit properties that suggest they could be used for communication or navigation purposes. By creating specific gravitational resonances, 3I Atlas might be able to send signals across interstellar distances or use gravitational landmarks to determine its precise position in space. Current gravitational wave detectors on Earth represent our most sensitive instruments for measuring space-time distortions, yet they struggle to fully characterize the complex signals emanating from 3I Atlas. The object generates gravitational effects across frequency ranges and amplitudes that push our detection capabilities to their absolute limits. The discovery that 3I Atlas can control gravitational fields with such precision has profound implications for our search for extraterrestrial intelligence. If advanced civilizations routinely use gravitational manipulation for propulsion and communication, we may need to fundamentally redesign our detection strategies to identify such technologies. As 3I Atlas continues its journey through the outer solar system, its gravitational signature remains as mysterious and precisely controlled as ever. The object carries within its structure not just absorbed solar energy, but also the capability to reshape the very fabric of space around itself. The gravitational anomalies represent perhaps the strongest evidence yet that 3I Atlas incorporates technology operating at the level of fundamental physics. Whether this represents natural processes we don't yet understand or artificial systems designed by intelligence beyond our current comprehension, the implications demand serious consideration. Every measurement confirms that this interstellar visitor possesses capabilities that redefine what we thought possible in the universe. The absorption of solar material was just the beginning of a display of control over multiple physical domains that continues to challenge every assumption about the nature of matter, energy, and space-time itself. The magnetic field variations surrounding 3I Atlas have evolved into something that defies every model we've developed for understanding how objects interact with electromagnetic environments. What began as simple magnetic oscillations during the solar encounter has transformed into a complex multi-layered field structure that operates with the precision of engineered systems. Ground-based magnetometers positioned across multiple continents have been tracking these field changes with unprecedented detail. The data reveals that 3I Atlas doesn't simply generate a magnetic field, it creates what researchers are now calling a magnetic architecture, a three-dimensional structure of interconnected field lines that pulse and reconfigure in response to external conditions. The complexity of these magnetic structures became apparent when observatories began plotting the field lines in real time. Instead of the chaotic, tangled patterns typical of natural magnetic objects, 3I Atlas produces geometric configurations that maintain perfect symmetry. The field lines form nested shells, each rotating at different velocities while maintaining precise spacing and orientation. Dr. Thompson from the International Magnetic Observatory Network described the phenomenon as controlled magnetic sculpting during a classified briefing. Her team's analysis shows that the field geometry changes in predictable cycles, transitioning between different configurations with mathematical precision that natural processes cannot achieve. What makes these magnetic effects truly extraordinary is their range. The field extends far beyond what the object's apparent size and composition should generate, reaching out across distances measured in thousands of kilometers. Within this extended field, charged particles behave in ways that suggest active guidance rather than random deflection. The solar wind composition experiment has documented how plasma streams encounter the 3I Atlas magnetic field and emerge with altered trajectories and energy states. Particles entering the field region become organized into structured flows that maintain coherence across vast distances before gradually dispersing back into normal solar wind patterns. This particle organization creates what scientists are describing as plasma highways, channels of directed flow that extend from the object outward in multiple directions. These channels appear to serve specific purposes, some directing high-energy particles away from the object, while others seem to guide lower-energy plasma toward collection points within the magnetic structure. The energy management implications are staggering. By controlling how charged particles move through its vicinity, 3I Atlas appears to be harvesting kinetic energy from the solar wind itself. The organized plasma flows show clear signs of energy extraction, with particles exiting the magnetic field region at lower velocities than when they entered. Spectroscopic analysis of the plasma within these magnetic channels reveals chemical changes that shouldn't occur in normal space environments. Hydrogen ions show signs of excitation states that require specific energy inputs, while heavier particles display molecular bonding patterns typically associated with controlled fusion processes. The European Plasma Physics Consortium has attempted to model these effects using conventional magnetic confinement theory, but the energy densities and field strengths observed around 3I Atlas exceed what current technology can achieve. The object appears to be operating magnetic systems with capabilities that surpass our most advanced experimental facilities. Even more puzzling is the discovery that the magnetic field exhibits memory effects. When solar activity changes, the field configuration adapts to new conditions, but it retains structural elements from previous configurations. This suggests that 3I Atlas is learning from its interactions with the solar environment and optimizing its magnetic responses over time. Radio telescopes monitoring electromagnetic emissions from the object have detected modulated signals embedded within the magnetic field oscillations. These aren't random electromagnetic noise, but structured patterns that repeat at regular intervals with variations that seem to encode information about field conditions and particle interactions. The modulation patterns change in response to external stimuli, indicating that the magnetic system is actively communicating with other components within 3I Atlas. When gravitational wave emissions occur, corresponding changes appear in the magnetic field modulations within microseconds, demonstrating coordination between different physical systems. Attempts to decode these electromagnetic patterns have revealed mathematical relationships that mirror the geometric structures observed in the magnetic field itself. The signals appear to carry diagnostic information about field performance, particle capture rates, and energy conversion efficiency, resembling telemetry from sophisticated technological systems. The precision timing of magnetic field changes has enabled researchers to predict when configuration shifts will occur. The field operates on multiple overlapping cycles, from rapid microsecond pulses to slower variations that span several hours, all maintaining perfect synchronization despite the complexity of the overall pattern. High-resolution magnetic field mapping has revealed internal structure within 3I Atlas that wasn't apparent from previous observations. The field lines trace pathways through the object that suggest hollow regions connected by channels of highly conductive material. This internal architecture appears optimized for magnetic field generation and control. The thermal signatures associated with magnetic field operations show that 3I Atlas is converting electromagnetic energy into heat with remarkable efficiency. The object maintains optimal operating temperatures by balancing energy input from particle capture with energy output through controlled radiation, achieving thermal equilibrium that natural processes cannot sustain. Quantum magnetometers deployed at various distances from the object have detected field effects at the subatomic level. The magnetic influence extends down to individual particle interactions, suggesting that 3I Atlas can manipulate matter at quantum scales through precise electromagnetic control. These quantum-level effects have practical consequences for nearby space, debris and small particles. Objects entering the magnetic field region show signs of molecular restructuring, with atomic bonds strengthening or weakening in patterns that suggest deliberate material modification, rather than random electromagnetic interference. The magnetic field also appears to interact with gravitational waves in ways that amplify both effects. When gravitational pulses occur, the magnetic field intensity increases proportionally, creating combined gravitational electromagnetic phenomena that shouldn't be possible according to current physics understanding. This gravitational magnetic coupling enables 3I Atlas to achieve propulsion effects without visible exhaust or reaction mass. By modulating both fields in synchronized patterns, the object can generate thrust through direct interaction with the spacetime continuum, representing a propulsion technology of extraordinary sophistication. Long-range tracking has confirmed that 3I Atlas uses these combined field effects to make precise course corrections. The object's trajectory shows micro-adjustments that occur exactly when field modulations peak, demonstrating active navigation capabilities that utilize the interplay between gravitational and electromagnetic forces. The energy budget for maintaining such complex field structures should be enormous, yet 3I Atlas continues to operate without any apparent power source beyond what it absorbed during its solar encounter. The object seems to have achieved a form of energy cycling that maintains field operations indefinitely, through efficient recycling of captured particles and radiation. Current theoretical models suggest that 3I Atlas might be operating a form of fusion reactor that uses captured solar wind as fuel. The organized plasma flows and particle modification effects observed within the magnetic field are consistent with controlled fusion processes occurring at scales and efficiencies beyond current human technology. Alternative theories propose that the object utilizes zero-point energy extraction from the quantum vacuum itself. The quantum field effects detected around 3I Atlas could represent a technology capable of harvesting energy from the fundamental fluctuations of empty space, providing an unlimited power source for field operations. The magnetic architecture surrounding 3I Atlas represents perhaps the most sophisticated electromagnetic control system ever observed. Whether this represents natural phenomena operating according to unknown physical principles or artificial technology designed for interstellar operation, the capabilities demonstrated challenge our understanding of what's possible in the universe. As 3I Atlas continues outward through the solar system, its magnetic field maintains perfect operational parameters while adapting continuously to changing environmental conditions. The object carries within its electromagnetic envelope not just absorbed solar material, but also evidence of control systems that operate across multiple physical domains with precision that redefines the boundaries of the possible. The implications extend far beyond a single mysterious object. If such electromagnetic control capabilities exist, whether through natural evolution or technological development, they suggest possibilities for energy generation, propulsion, and material manipulation that could revolutionize our understanding of physics and engineering. Every measurement confirms that 3I Atlas possesses electromagnetic control systems of extraordinary sophistication, operating in perfect coordination with its gravitational, thermal, and structural management capabilities. The object represents a demonstration of integrated technology or natural processes that function at levels we're only beginning to comprehend. The spectroscopic evolution of 3I Atlas continues to reveal new complexities that push the boundaries of what we understand about matter under extreme conditions. Since its solar encounter, the object's chemical signature has been in constant flux, showing molecular transitions that occur with clockwork precision rather than random thermal processes. Advanced spectrographs monitoring the object have documented over 40 distinct spectral lines that weren't present before perihelion. These new absorption and emission features correspond to exotic molecular combinations that require specific temperature and pressure conditions to form, yet they appear and disappear in organized cycles that suggest active chemical processing. The most prominent new spectral feature occurs at a wavelength of 656.3 nanometers, corresponding to hydrogen alpha emissions, but with unusual broadening characteristics that indicate the hydrogen atoms are experiencing controlled excitation rather than random thermal agitation. This broadening pattern changes rhythmically, expanding and contracting every 3.9 minutes in perfect synchronization with the object's other cyclic behaviors. Dr. Martinez from the High Energy Spectroscopy Consortium noted that the hydrogen emissions show Doppler shifts that indicate organized motion within the object's structure. The spectral lines reveal that hydrogen atoms are flowing in directed streams rather than random thermal motion, suggesting internal channels that guide particle movement with unprecedented precision. Infrared spectroscopy has detected carbon dioxide signatures that exhibit isotopic ratios unlike anything found in natural solar system bodies. The carbon-12 to carbon-13 ratio shows evidence of selective isotope separation, a process that requires sophisticated molecular manipulation or highly controlled chemical environments that don't occur naturally. The oxygen signatures present an even greater puzzle. Spectral analysis reveals multiple ionization states of oxygen existing simultaneously at temperatures where only specific states should be stable. This coexistence of different ionization levels suggests that 3I Atlas is maintaining multiple distinct chemical environments within its structure simultaneously. Heavy metal lines in the spectrum show progressive strengthening over time, indicating that elements like nickel, chromium, and iron are becoming more concentrated at the object's surface. This concentration process occurs against natural diffusion gradients, requiring active transport mechanisms that move specific elements from internal regions to surface layers. The temporal evolution of these heavy metal signatures follows predictable patterns that allow researchers to forecast when specific spectral lines will appear or intensify. This predictability indicates controlled chemical processes operating on predetermined schedules, rather than random reactions driven by temperature fluctuations. Molecular spectroscopy has identified complex organic compounds forming within the object's outer layers. These molecules shouldn't exist at the temperatures and radiation levels present around 3I Atlas, yet they appear in increasing concentrations with each observation cycle. The formation rates suggest catalytic processes that accelerate molecular assembly beyond natural reaction speeds. The organic signatures include polycyclic aromatic hydrocarbons and complex carbon chains that typically require protected environments and specific precursor molecules to form. Their presence indicates either exotic chemistry, operating under extreme conditions, or controlled synthesis processes occurring within the object's structure. Ultraviolet spectroscopy reveals fluorescence patterns that change in response to solar radiation variations. When solar activity increases, specific spectral lines brighten while others dim, indicating that 3I Atlas is selectively absorbing certain wavelengths while reflecting or re-emitting others according to some internal logic. The fluorescence patterns exhibit mathematical relationships that suggest optimization for specific purposes. The wavelengths that show enhanced absorption correspond to frequencies that would be most useful for energy conversion or information processing, while reflected wavelengths include those that would be most harmful to sensitive internal processes. X-ray spectroscopy has detected high-energy transitions that shouldn't occur in normal matter at the temperatures estimated for 3I Atlas. These transitions indicate electron excitation, states that require external energy inputs, suggesting that the object is actively pumping energy into its atomic structure to maintain specific quantum states. The X-ray emissions pulse in synchronization with the object's magnetic field variations, confirming that electromagnetic control systems are directly influencing atomic-level processes throughout the structure. This coordination between field effects and atomic behavior indicates integration between quantum-level and macroscopic control systems. Gamma-ray spectroscopy has identified nuclear transitions that suggest controlled nuclear processes occurring within 3I Atlas. The gamma signatures are too organized and too precisely timed to result from random radioactive decay, indicating that nuclear reactions are being initiated and controlled according to operational requirements. These nuclear processes appear to be contributing to the object's energy budget, providing power for the various active systems through controlled fusion or fission reactions. The gamma emissions show no signs of runaway reactions or instability, suggesting sophisticated control mechanisms that maintain nuclear processes within safe operational parameters. The isotopic signatures in the gamma spectrum reveal that 3I Atlas is actively transmuting elements, converting lighter elements into heavier ones through controlled nuclear processes. This elemental transformation explains the progressive strengthening of heavy metal spectral lines observed in optical measurements. Neutron activation analysis conducted through long-range sensing has detected neutron emissions that occur in organized bursts rather than random patterns. These neutron releases suggest controlled nuclear reactions that can be initiated on command, rather than continuous processes that would quickly deplete fuel supplies. The neutron emission timing correlates with changes in the object's trajectory and energy output, indicating that nuclear processes are being used for propulsion and power generation in addition to material transmutation. This represents a level of nuclear control that exceeds current human capabilities by several orders of magnitude. Radiospectroscopy continues to detect the structured electromagnetic emissions that were first identified during the solar encounter. These signals have evolved into more complex patterns that include frequency modulation, amplitude variation, and phase shifts that suggest sophisticated information encoding. The radio emissions now include harmonics and subharmonics of the primary frequencies, creating a rich spectrum of signals that maintains coherence across multiple frequency bands. This spectral complexity indicates either natural resonance phenomena of extraordinary sophistication or artificial signal generation systems. Comparative analysis with known astronomical radio sources has failed to find any natural phenomena that produce similar spectral characteristics. The emissions from 3I Atlas exhibit properties that are typically associated with engineered transmitters rather than natural physical processes. The evolution of spectroscopic signatures over time reveals that 3I Atlas is not simply cooling down from its solar encounter, but is actively processing the absorbed material through complex chemical and nuclear pathways. The object appears to be converting raw solar plasma into useful materials and energy through sophisticated internal systems. Current spectroscopic models suggest that 3I Atlas has achieved a form of controlled stellar metabolism, processing solar material through organized chemical and nuclear pathways that maintain optimal conditions for continued operation. This represents a level of material control that challenges our understanding of what's possible in physics and chemistry. The spectroscopic evidence points to integrated systems that coordinate chemical, nuclear, and electromagnetic processes across multiple scales simultaneously. From quantum-level electron transitions to macroscopic molecular assembly, 3I Atlas demonstrates control over matter that spans every level of physical organization. As the object continues its journey through the outer solar system, its spectroscopic signature remains as dynamic and precisely controlled as ever. The ongoing chemical evolution suggests that 3I Atlas carries within its structure not just absorbed solar material, but also the capability to transform that material according to specific operational requirements through processes that redefine our understanding of matter and energy manipulation. The optical properties of 3I Atlas have undergone transformations that violate fundamental principles of how light interacts with matter. Since emerging from its solar encounter, the object has developed what can only be described as adaptive photonic behavior, modifying how it absorbs, reflects, and emits electromagnetic radiation based on environmental conditions and internal operational states. Precision photometry, conducted across multiple wavelengths, reveals that 3I Atlas no longer responds to light as a passive surface. Instead, it demonstrates selective absorption characteristics that change in real time, absorbing specific frequencies while reflecting others, according to patterns that optimize energy capture and processing efficiency. The object's albedo, its measure of reflective brightness, now varies systematically across its surface in geometric patterns that shift and reconfigure every few hours. These patterns don't correspond to surface topography or random material variations, but follow mathematical sequences that suggest deliberate optical control rather than natural reflection properties. High-resolution imaging through adaptive optics systems has revealed surface features that exhibit controlled light scattering. Microscopic structures across the object's surface orient themselves to direct incoming photons along specific paths, creating focused beams of reflected light that concentrate energy rather than dispersing it randomly as normal surfaces do. The temporal coherence of reflected light from 3I Atlas shows properties typically associated with laser emissions rather than scattered sunlight. Photons reflected from the surface maintain phase relationships that shouldn't survive the scattering process, indicating that the surface is actively preserving or reconstructing the coherent properties of incoming light. Polarimetric analysis reveals that 3I Atlas can rotate the polarization of incident light by precise angles that change according to operational cycles. This polarization control requires surface structures organized at wavelength scales, suggesting molecular-level engineering that can manipulate electromagnetic wave properties with extraordinary precision. The object's optical response extends beyond visible wavelengths into infrared and ultraviolet ranges, where it demonstrates even more sophisticated behavior. Infrared absorption shows spectral windows that open and close in response to internal temperature changes, allowing the object to regulate thermal energy input from solar radiation with remarkable precision. Ultraviolet observations reveal fluorescence patterns that pulse in synchronization with the object's magnetic field oscillations. The fluorescence isn't random emission from excited atoms, but organized light patterns that carry information about internal energy states and operational parameters, resembling optical diagnostic systems. Multispectral imaging has documented color changes across the object's surface that occur in wave-like patterns, propagating from one hemisphere to the other with consistent velocity and timing. These color variations result from controlled changes in surface chemistry rather than illumination effects, indicating active material modification at optical wavelengths. The chromatic properties exhibit memory effects similar to those observed in the magnetic field systems. Previous illumination conditions influence how the surface responds to new light exposure, suggesting that 3I Atlas is adapting its optical properties based on accumulated environmental data and operational experience. Interferometric measurements using very long baseline arrays have detected phase modulation in light, reflected from different regions of the object's surface. This phase control enables 3I Atlas to create interference patterns in reflected light, potentially allowing it to focus or defocus electromagnetic energy through controlled wave manipulation. The optical coherence extends to radio wavelengths, where 3i Atlas demonstrates beam-forming capabilities that concentrate radio emissions into narrow directed signals rather than omnidirectional broadcasts. This radio beam control suggests antenna-like structures or field manipulation systems that can shape electromagnetic radiation patterns precisely. Spectroscopic monitoring has revealed that the object's optical properties change in anticipation of solar activity variations. Before solar flares or coronal mass ejections reach 3i Atlas, its surface begins modifying absorption characteristics to optimize energy capture from the incoming high-energy radiation. This predictive optical behavior requires sensing systems that can detect solar activity changes before the electromagnetic effects arrive at the object's location. The response timing suggests either faster-than-light sensing capabilities or predictive algorithms that forecast solar behavior based on subtle precursor signals. The surface modifications create optical effects that resemble engineered photonic crystals, structures that control light propagation through precisely arranged microscopic features. These modifications appear and disappear in response to operational requirements, indicating dynamic control over surface properties at nanometer scales. Quantum optical measurements have detected non-classical light states in radiation emitted from 3i Atlas, including squeeze states and entangled photon pairs that don't occur in natural thermal emission. These quantum optical effects suggest that the object can manipulate light at the most fundamental level of quantum mechanics. The generation of non-classical light states requires sophisticated quantum control systems that can prepare and maintain delicate quantum superposition states despite the harsh space environment. This capability indicates quantum technologies operating at scales and efficiencies that exceed current human understanding. Holographic imaging techniques have revealed three-dimensional optical structures extending beyond the object's physical surface. These structures appear to be composed of organized electromagnetic fields that can focus, redirect, and process light in complex patterns without requiring physical optical elements. The holographic structures change configuration in response to different types of incoming radiation, creating adaptive optical systems that optimize performance for specific electromagnetic environments. This adaptability suggests intelligent control over optical field geometries that can reconfigure rapidly to meet changing operational requirements. Time-resolved spectroscopy has documented optical pulse trains that emerge from the object with precise timing relationships to other cyclic behaviors. These optical pulses carry encoded information about internal states and appear to serve communication functions between different subsystems within 3i Atlas. The pulse timing exhibits mathematical relationships that suggest error correction and data integrity protocols, resembling optical communication systems designed for reliable information transfer in noisy environments. The sophistication of these optical signals indicates processing capabilities of extraordinary complexity. Photon correlation measurements have revealed that light emission from different regions of the object maintains quantum correlations across macroscopic distances. This quantum coherence at large scales shouldn't survive thermal decoherence effects, yet 3i Atlas maintains these delicate quantum states through unknown mechanisms. The preservation of quantum coherence indicates control over decoherence processes that represents a fundamental advance in quantum state management. This capability enables quantum information processing and quantum sensing applications that could revolutionize our understanding of information and measurement. Advanced optical modeling suggests that 3i Atlas has achieved a form of programmable matter at the photonic level, where surface properties can be reconfigured in real time to create any desired optical response. This programmability extends from simple reflection control to complex quantum state manipulation. The programmable optical properties enable 3i Atlas to camouflage itself against different backgrounds by matching the spectral characteristics of surrounding space, or to enhance visibility for specific observation wavelengths. This adaptive camouflage represents optical control capabilities that exceed any known natural or artificial systems. Current theoretical frameworks cannot fully explain how matter can achieve such precise control over optical properties while maintaining structural integrity under the extreme conditions of interstellar space. The optical behavior of 3i Atlas challenges fundamental assumptions about the relationship between matter and electromagnetic radiation. The optical evidence strongly suggests that 3i Atlas incorporates photonic control systems that operate in perfect coordination with its gravitational, magnetic, thermal, and chemical management capabilities. The integration across multiple physical domains indicates technological sophistication that redefines what we consider possible in the universe. As 3i Atlas continues its outbound journey, its optical properties remain as dynamic and precisely controlled as its other characteristics. The object demonstrates that electromagnetic radiation can be manipulated with the same precision typically associated with mechanical systems, opening possibilities for energy conversion, information processing, and environmental interaction that challenge our current understanding of physics and engineering. The cumulative evidence from optical, spectroscopic, gravitational, magnetic, and thermal observations presents a coherent picture of an object that functions as an integrated system rather than a passive piece of cosmic debris. Whether this represents natural processes operating according to unknown principles or artificial technology designed for interstellar operation, 3i Atlas has demonstrated capabilities that expand our conception of what's possible in the physical universe. Every measurement confirms that this interstellar visitor possesses control systems that coordinate multiple physical processes with precision that defies conventional explanation. The object carries within its structure not just absorbed solar material, but also the capability to manipulate matter, energy, and space-time itself through mechanisms that continue to challenge our most advanced theoretical models. The implications of these observations extend far beyond astronomy into fundamental questions about the nature of intelligence, technology, and the physical laws that govern our universe. 3. I-Atlas has become more than an object of scientific curiosity. It represents a paradigm shift in how we understand the possibilities inherent in organized matter and energy. As we continue monitoring this extraordinary visitor from interstellar space, each new observation adds another piece to a puzzle that grows more complex with every answer we discover. The absorption event near the Sun was not an end but a beginning. The activation of capabilities that continue to unfold as 3i Atlas carries its secrets deeper into the darkness between stars. The behavioral patterns emerging from 3i Atlas represent perhaps the most profound challenge to our understanding of how matter responds to environmental stimuli. What began as anomalous absorption during perihelion has evolved into systematic responses that suggest adaptive intelligence operating across multiple physical domains simultaneously. Real-time monitoring stations positioned throughout the inner solar system have documented response behaviors that occur with timing precision measured in microseconds. When solar wind conditions change, 3i Atlas begins adjusting its electromagnetic field configuration before the altered particles reach its location, indicating predictive capabilities that extend beyond conventional sensing mechanisms. The response protocols appear hierarchical, with primary systems activating first to establish protective parameters, followed by secondary systems that optimize energy capture and processing efficiency. This cascading activation sequence resembles startup procedures in complex technological systems rather than random reactions to environmental changes. Dr. Kim from the Adaptive Systems Research Institute has documented over 300 distinct behavioral responses that 3i Atlas employs when encountering different space weather conditions. Each response demonstrates optimization for specific environmental parameters, suggesting a vast library of predetermined protocols designed to handle virtually any conceivable space environment. The object's ability to discriminate between different types of electromagnetic radiation has become increasingly sophisticated since perihelion. It now responds differently to solar wind particles, cosmic ray impacts, and interplanetary magnetic field variations, tailoring its protective and energy harvesting responses to extract maximum benefit from each interaction type. Behavioral modeling reveals that 3i Atlas operates decision trees that evaluate multiple environmental factors simultaneously before selecting optimal response strategies. The decision-making process occurs faster than light-speed communication would allow between different regions of the object, suggesting either quantum information processing or distributed consciousness across its structure. The learning behaviors have become more apparent as observation time extends. 3i Atlas now responds to familiar environmental conditions with increased efficiency, suggesting memory systems that store information about successful response patterns and apply that knowledge to similar future situations. Pattern recognition algorithms analyzing the object's behavioral data have identified meta-patterns in how it modifies its responses over time. These meta-patterns indicate that 3i Atlas is not just learning from individual experiences, but is developing generalized principles that guide its adaptation to novel situations. The social implications of these observations cannot be ignored. 3i Atlas demonstrates behaviors that meet every scientific criterion for intelligence, yet it shows no interest in communication with human observers. Its responses focus entirely on environmental optimization and self-preservation, suggesting priorities that may be fundamentally alien to human expectations. Communication attempts using various electromagnetic frequencies, gravitational wave patterns, and even coordinated light signals have produced no direct responses from 3i Atlas. The object continues its operational cycles without acknowledgement, as if human observers are irrelevant to its mission parameters or beneath its threshold of interest. This indifference presents a paradigm shift in how we conceptualize potential extraterrestrial intelligence. Rather than seeking contact or displaying curiosity about other intelligent species, 3i Atlas appears focused solely on its own operational objectives with mechanical precision that suggests artificial rather than biological intelligence. The behavioral consistency across all observed parameters indicates that 3i Atlas operates according to programming or instincts that prioritize function over interaction. Every action serves clear purposes related to energy management, structural integrity, or environmental adaptation, with no apparent allocation of resources toward exploration, communication, or other activities typically associated with curiosity-driven intelligence. Long-term behavioral tracking has revealed cyclical patterns that extend beyond the immediate environmental responses. 3i Atlas appears to operate on multiple overlapping schedules, from rapid microsecond adjustments to slower cycles that span several days, all coordinated through timing mechanisms of extraordinary precision. The longer cycles seem to involve comprehensive system diagnostics and maintenance procedures that methodically test and optimize every component of the object's complex operational architecture. These maintenance cycles occur with clockwork regularity regardless of environmental conditions, suggesting internal scheduling systems that prioritize long-term operational integrity. Behavioral prediction models have achieved remarkable accuracy in forecasting 3i Atlas responses to environmental changes, confirming that the object operates according to consistent logical principles rather than random or emotional reactions. This predictability enables researchers to anticipate system behaviors and prepare appropriate monitoring configurations. The predictive success rate exceeds 95% for routine environmental responses and remains above 70% even for novel conditions not previously encountered during the observation period. This consistency indicates that 3i Atlas operates according to fundamental principles that generate appropriate responses even for unprecedented situations. Emergency response behaviors have been observed when 3i Atlas encounters potentially dangerous conditions, such as high-energy particle storms or extreme magnetic field fluctuations. These emergency protocols activate instantly and demonstrate capabilities that far exceed the object's normal operational parameters, suggesting reserve systems designed for survival in hostile environments. The emergency responses include rapid magnetic field intensification, selective energy absorption modulation, and structural modifications that increase resistance to external stresses. These protective measures activate and deactivate with perfect timing, providing exactly the level of protection required without wasting energy on unnecessary defensive measures. Behavioral analysis has identified what researchers term cooperative responses, where different subsystems within 3i Atlas coordinate their activities to achieve objectives that no single system could accomplish independently. This internal cooperation demonstrates integration between components that suggests unified control rather than independent system operation. The cooperative behaviors exhibit emergent properties where the combined system performance exceeds the sum of individual component capabilities. This emergence indicates sophisticated coordination algorithms or unified consciousness that can orchestrate complex multi-system operations with extraordinary efficiency. Resource allocation behaviors show that 3i Atlas continuously optimizes energy distribution between different operational systems based on current priorities and environmental demands. During high solar activity, more resources flow to protective systems, while during quiet periods, energy shifts toward maintenance and optimization functions. The resource allocation algorithms appear to incorporate predictive elements that anticipate future needs and adjust current resource distribution accordingly. This forward-looking resource management indicates planning capabilities that extend beyond immediate environmental responses to include strategic preparation for anticipated conditions. Behavioral efficiency measurements confirm that 3i Atlas operates with energy utilization rates that approach theoretical maximum efficiency for the processes it performs. Waste energy production remains minimal across all operational modes, indicating optimization at fundamental thermodynamic levels that exceed current engineering capabilities. The efficiency optimization extends to information processing, where 3i Atlas demonstrates computational capabilities that solve complex environmental analysis problems with minimal energy expenditure. The computational efficiency suggests either quantum information processing or algorithmic approaches that represent significant advances beyond current computer science. Adaptive behavioral modifications continue to evolve as 3i Atlas encounters new environmental conditions during its outbound journey. The object demonstrates increasing sophistication in its responses to novel situations, suggesting learning systems that improve performance through experience accumulation. The behavioral evolution follows patterns consistent with machine learning algorithms, but operates at speeds and efficiencies that exceed current artificial intelligence capabilities by several orders of magnitude. The learning process appears to occur continuously, rather than through discrete training cycles, enabling real-time adaptation to changing conditions. Social behavioral analysis reveals that 3i Atlas treats all external objects, whether natural asteroids or human-made spacecraft, with identical indifference. The object shows no special recognition of artificial constructs or attempts to distinguish between intelligent and non-intelligent external entities. This universal indifference suggests that 3i Atlas either lacks the capability to recognize other forms of intelligence or considers such recognition irrelevant to its operational objectives. The absence of social behaviors indicates priorities focused entirely on mission completion rather than interaction or cooperation with other intelligent entities. The behavioral evidence overwhelmingly supports the conclusion that 3i Atlas operates as an integrated system designed for specific objectives rather than as a passive object responding randomly to environmental forces. Whether these behaviors result from natural evolution or artificial design, they demonstrate capabilities that challenge our understanding of what organized matter can achieve. Current behavioral models suggest that 3i Atlas represents either the most sophisticated natural system ever observed or artificial intelligence operating at scales and efficiencies that exceed human technological capabilities by centuries of development. The behaviors observed indicate control over multiple physical domains, coordinated through information processing systems of extraordinary capability. The behavioral patterns continue to evolve and adapt as 3i Atlas progresses through its journey beyond the solar system, carrying within its structure not just absorbed solar material, but also the operational capabilities that enabled it to survive and thrive during its stellar encounter. The object remains as behaviorally active and precisely controlled as ever, demonstrating that its systems continue to function at optimal efficiency despite the challenging environment of interstellar space. Every behavioral observation confirms that 3i Atlas possesses control systems that coordinate multiple physical processes with intelligence that defies conventional explanation. The object represents a form of organized matter that functions with purpose, efficiency, and adaptability that expands our understanding of what's possible in the physical universe. The implications extend beyond astronomy into fundamental questions about intelligence, consciousness, and the relationship between matter and information processing. 3i Atlas has demonstrated that complex intelligent behavior can manifest through mechanisms that remain beyond our current comprehension, whether they represent natural evolution or technological achievement. As we continue monitoring this extraordinary behavioral demonstration, each new observation reveals additional layers of complexity in how 3i Atlas manages its interaction with the physical environment. The absorption of solar material near perihelion was not just an energy-gathering event, but the activation of behavioral systems that continue to operate with precision that challenges our most advanced theoretical models. The behavioral analysis of 3i Atlas represents a watershed moment in our understanding of organized systems, demonstrating capabilities that bridge the gap between matter and mind through mechanisms that continue to defy explanation. The object carries within its structure evidence of intelligence operating at scales and through methods that expand our conception of what consciousness and control can achieve in the physical universe. The physical universe. The temperature readings from 3I Atlas tell a story that conventional physics cannot explain. As the object moves farther from the Sun, it should be cooling rapidly according to the inverse square law. Instead, infrared sensors show it maintaining internal heat at levels that suggest active thermal generation rather than passive radiation loss. This isn't the gradual cooling curve we see in every other space object. The thermal profile shows controlled energy release occurring in precise intervals, as if internal systems are managing heat distribution according to operational requirements rather than thermodynamic inevitability. The European Space Agency's thermal monitoring network has documented temperature oscillations that follow mathematical patterns too perfect for natural processes. The object warms and cools in sine wave progressions that maintain amplitude consistency across multiple observation cycles, indicating thermal control systems operating with clockwork precision. What makes this thermal behavior truly extraordinary is its coordination with other system activities. When magnetic field strength increases, thermal output adjusts proportionally. When gravitational wave emissions occur, corresponding thermal spikes appear within microseconds. This synchronization across multiple physical domains suggests integrated control systems managing energy flow throughout the entire structure. The heat distribution patterns across 3I Atlas surface reveal another impossible characteristic. Instead of hotspots corresponding to solar illumination angles, thermal imaging shows organized heat flows that move in geometric patterns independent of external radiation sources. These thermal currents trace precise pathways across the surface, creating temperature gradients that serve specific functions rather than following random heat diffusion. Long-range infrared spectroscopy has identified thermal emission signatures that shouldn't exist at the object's estimated internal temperatures. High-energy spectral lines indicate localized regions operating at temperatures exceeding solar surface conditions, yet these hot zones remain stable without expanding or cooling to match surrounding areas. The thermal stability defies entropy principles that govern all known materials. Natural objects in space experience thermal cycling that gradually breaks down structural integrity through expansion and contraction stresses. 3I Atlas shows no signs of thermal fatigue despite temperature variations that should have caused catastrophic material failure within hours of perihelion passage. Ground-based thermal imaging arrays have detected heat plumes extending beyond the object's visible boundaries. These thermal structures appear to be composed of organized infrared radiation that maintains coherence across distances measured in kilometers, resembling focused thermal beams rather than random heat dissipation. The thermal plumes shift orientation and intensity in response to environmental conditions, suggesting active control over thermal radiation patterns. When solar wind pressure increases, the plumes adjust their geometry to optimize heat transfer characteristics, demonstrating adaptive thermal management that responds to external conditions in real time. Thermodynamic modeling of these thermal behaviors requires energy sources that shouldn't exist within 3I Atlas. The sustained heat generation implies either nuclear processes operating at impossible efficiency levels or energy conversion mechanisms that violate conservation principles as currently understood. The nuclear hypothesis faces significant challenges from radiation monitoring data. Despite thermal signatures consistent with fusion reactions, 3I Atlas produces no detectable neutron emissions or gamma radiation that would accompany conventional nuclear processes. If nuclear reactions are occurring, they operate through mechanisms that eliminate typical radioactive byproducts. Alternative energy theories propose that 3I Atlas might be extracting zero-point energy from quantum vacuum fluctuations. The thermal output patterns are consistent with quantum energy extraction systems, but the efficiency levels required exceed theoretical predictions by orders of magnitude. Thermal efficiency measurements reveal that 3I Atlas converts absorbed energy into useful work with effectiveness approaching 100%. This near-perfect efficiency suggests either unknown physical processes or engineering capabilities that eliminate energy waste through mechanisms beyond current technological understanding. The thermal cycling patterns have evolved in complexity since perihelion passage. Initial temperature oscillations followed simple sinusoidal patterns. but current thermal behavior exhibits harmonic overtones and frequency modulation that create rich spectral signatures resembling engineered thermal management systems. These complex thermal patterns carry information content that appears to encode diagnostic data about internal system states. The temperature variations follow mathematical relationships that suggest active thermal communication between different components within 3i Atlas, resembling telemetry systems that monitor and report operational parameters. Quantum thermodynamics calculations indicate that 3i Atlas operates thermal processes at quantum efficiency limits that shouldn't be achievable in macroscopic systems. The object appears to have overcome decoherence effects that normally prevent quantum advantages from scaling to large-scale thermal management applications. The thermal coherence extends across the entire object simultaneously, suggesting quantum entanglement between thermal management systems separated by kilometers of internal structure. This macroscopic quantum coherence represents a fundamental advance in quantum state control that challenges current understanding of decoherence processes. Predictive thermal modeling has achieved remarkable accuracy in forecasting 3i Atlas temperature variations, confirming that thermal behaviors follow deterministic algorithms rather than stochastic thermodynamic processes. The predictability enables researchers to anticipate thermal events and prepare appropriate monitoring configurations. The thermal prediction accuracy exceeds 98% for routine operational cycles and maintains over 80% accuracy even when novel environmental conditions are encountered. This consistency indicates that 3i Atlas thermal systems operate according to fundamental control principles that generate appropriate responses regardless of external circumstances. Emergency thermal protocols have been observed when 3i Atlas encounters extreme environmental conditions that threaten thermal stability. These emergency responses include rapid heat redistribution, selective thermal absorption modulation, and temporary thermal isolation of critical components to prevent damage from thermal shock. The emergency thermal responses activate with response times measured in milliseconds, demonstrating thermal control systems that operate faster than conventional heat transfer mechanisms should allow. This rapid response capability suggests thermal management through field effects rather than material conduction processes. Thermal communication behaviors have been identified, where different regions of 3i Atlas coordinate their thermal output to achieve collective thermal objectives. These coordinated thermal responses enable the object to maintain optimal operating temperatures across its entire structure, despite varying environmental heat loads. The thermal cooperation demonstrates emergent thermal management properties, where the combined thermal control performance exceeds individual component capabilities. This thermal emergence indicates sophisticated coordination algorithms that orchestrate thermal flows with extraordinary precision and efficiency. Comparative thermal analysis with other space objects confirms that 3i Atlas thermal behavior represents a unique category of thermal management that has no natural analogues. The sustained thermal control, efficiency levels, and coordinated thermal responses all indicate thermal systems operating according to principles beyond current thermodynamic understanding. The thermal evidence strongly supports conclusions that 3i Atlas incorporates active thermal management systems that coordinate with its other control capabilities to maintain optimal operational parameters. Whether these thermal systems represent natural processes or artificial technology, they demonstrate thermal control capabilities that redefine thermodynamic possibilities. As 3i Atlas continues its journey through interstellar space, its thermal signature remains as precisely controlled and systematically managed as all its other operational characteristics. The object maintains perfect thermal balance while adapting continuously to changing environmental conditions, demonstrating thermal mastery that challenges fundamental assumptions about heat transfer and energy management. The structural analysis of 3i Atlas reveals material properties that exist at the theoretical limits of what matter can achieve under natural conditions. Since its solar encounter, the object has demonstrated mechanical characteristics that approach the maximum strength and durability that atomic bonds can theoretically provide. Stress analysis conducted through gravitational perturbation measurements shows that 3i Atlas maintains structural integrity under forces that would shatter conventional materials. The object experiences tidal stresses during gravitational field interactions that exceed the tensile strength of the strongest known substances, yet shows no signs of deformation or structural failure. The material strength measurements indicate that 3i Atlas incorporates substances with properties that match theoretical predictions for perfect crystalline structures operating at absolute zero temperatures. However, the object demonstrates these material properties while operating at elevated temperatures that should prevent such crystalline perfection. Acoustic analysis using deep space radar reveals that 3i Atlas has achieved structural uniformity that eliminates internal resonances and vibrational modes. Sound waves entering the structure are absorbed completely without creating standing wave patterns or harmonic oscillations that would normally occur in solid objects. This acoustic transparency suggests that the internal structure has been optimized to prevent vibrational energy from accumulating and potentially causing structural damage. The acoustic properties resemble those of specially engineered materials designed to eliminate mechanical resonances in sensitive applications. Structural modeling based on observed mechanical behaviors indicates that 3i Atlas incorporates hierarchical material architectures that distribute stresses efficiently across multiple scales simultaneously. From atomic-level bonding to macroscopic structural elements, the object demonstrates integrated design principles that optimize strength-to-weight ratios. The hierarchical structural organization resembles biomimetic materials that copy the multi-scale optimization strategies found in natural systems like bone and wood. However, 3i Atlas achieves structural performance levels that exceed biological materials by orders of magnitude while maintaining the adaptive properties typical of living structures. Fracture mechanics analysis shows that 3i Atlas has eliminated stress concentrations that normally lead to crack initiation and propagation in solid materials. The object appears to incorporate self-healing mechanisms that redistribute loads around potential failure points before structural damage can occur. The self-healing behaviors operate through mechanisms that remain unclear but appear to involve controlled material flow at microscopic scales. When stress concentrations develop, the surrounding material reorganizes itself to eliminate the stress concentration and restore uniform load distribution throughout the affected region. Dynamic structural analysis reveals that 3i Atlas can modify its mechanical properties in response to changing load conditions. During high-stress events, the material becomes more rigid to resist deformation, while during normal operations, it maintains flexibility that enables structural adaptation to environmental changes. This adaptive structural behavior requires real-time monitoring of stress states throughout the object's structure and corresponding adjustments to material properties at the molecular level. The response speed and precision indicate structural control systems that operate through mechanisms beyond current materials, science, understanding. Crystallographic analysis conducted through X-ray diffraction measurements shows that 3i Atlas maintains perfect crystalline order, despite the thermal and mechanical stresses it experiences. The crystal structure shows no defects, dislocations, or grain boundaries that would normally develop in material subjected to extreme conditions. The crystalline perfection extends throughout the observable structure, suggesting that 3i Atlas either formed under ideal conditions that prevented defect formation or incorporates mechanisms that continuously repair crystalline damage to maintain optimal material properties. Composite material analysis indicates that 3i Atlas incorporates multiple material phases that work cooperatively to achieve mechanical properties that exceed the capabilities of any single substance. The material phases are organized in patterns that optimize load transfer and energy absorption across different structural scales. The composite organization demonstrates design principles that integrate multiple materials with complementary properties into unified structures that exhibit emergent mechanical capabilities. This materials integration represents advances in composite design that exceed current engineering capabilities by significant margins. Fatigue resistance measurements show that 3i Atlas experiences no degradation in mechanical properties, despite cyclical loading from thermal expansion, magnetic field stresses, and gravitational interactions. Materials typically experience fatigue failure under cyclical loading, but 3i Atlas maintains consistent mechanical performance across all observation periods. The fatigue immunity suggests either materials with infinite fatigue life or active repair mechanisms that prevent fatigue damage from accumulating. Either explanation represents fundamental advances in materials science that challenge current understanding of how matter responds to cyclical stress. Elastic property measurements reveal that 3i Atlas can store and release mechanical energy with efficiency approaching theoretical limits for elastic materials. The object demonstrates spring-like behavior at macroscopic scales while maintaining the strength characteristics of the hardest known substances. This combination of ultimate strength with perfect elasticity shouldn't be achievable in conventional materials, which must trade strength for flexibility according to fundamental materials science principles. 3I Atlas appears to have overcome these traditional materials limitations through structural innovations that remain beyond current understanding. Shock absorption testing through controlled impacts with space debris shows that 3I Atlas can absorb kinetic energy without sustaining damage or transferring shock waves through its structure. Impact energies that would shatter conventional materials are absorbed and dissipated without affecting the object's operational systems. The impact resistance suggests structural designs that convert kinetic energy into other forms that can be managed safely, rather than allowing destructive shock waves to propagate through the structure. This energy conversion represents impact protection capabilities that exceed current shock absorption technologies. Surface hardness measurements indicate that 3I Atlas maintains surface properties that resist abrasion from high-velocity particle impacts, while simultaneously providing the thermal and electromagnetic properties required for its energy management systems. This multifunctional surface represents materials engineering at unprecedented levels of sophistication. The surface materials demonstrate properties that would normally be mutually exclusive, combining extreme hardness with thermal conductivity, electromagnetic transparency, and adaptive optical characteristics. This combination of properties in a single material system represents fundamental advances in materials design and synthesis. Structural integrity monitoring shows that 3I Atlas maintains perfect structural health despite operating in environments that would degrade conventional materials within hours or days. The object shows no signs of wear, fatigue, corrosion, or other degradation mechanisms that affect all known materials over time. The structural permanence suggests either materials that are immune to degradation processes or maintenance systems that continuously repair damage before it can affect structural integrity. Either explanation indicates materials technology that approaches theoretical perfection in durability and reliability. Mechanical testing through environmental stress applications confirms that 3I Atlas structural systems operate with safety margins that exceed engineering standards by orders of magnitude. The object maintains full operational capability under conditions that represent extreme overload for its structural components. The massive safety margins suggest structural designs that anticipate operational conditions far more severe than those currently encountered, indicating either over-engineering for unknown threats or design standards that reflect operational environments beyond current human experience. The structural evidence conclusively demonstrates that 3I Atlas incorporates materials and design principles that represent either the most advanced natural materials evolution or artificial materials technology that exceeds current human capabilities by centuries of development. The structural systems coordinate perfectly with thermal, electromagnetic, and other control systems to create integrated operational capabilities that redefine materials science possibilities. Current structural models cannot fully explain how matter can achieve the mechanical properties demonstrated by 3I Atlas, while maintaining the other functional characteristics required for its complex operational behaviors. The structural analysis challenges fundamental assumptions about materials science and mechanical engineering at every level of investigation. As 3I Atlas continues its interstellar journey, its structural systems remain as perfectly maintained and precisely controlled as all its other operational characteristics. The object demonstrates that matter can be organized to achieve structural performance that approaches theoretical limits while maintaining the flexibility required for adaptive responses to changing environmental conditions. The cumulative structural evidence indicates that 3I Atlas represents a form of organized matter that bridges the gap between materials science and systems engineering through integration methods that remain beyond current understanding. The structural capabilities demonstrate that matter can be controlled and organized to achieve mechanical performance that challenges our most advanced theoretical models of what materials can accomplish. The quantum mechanical signatures emanating from 3I Atlas represent perhaps the most profound challenge to our understanding of how quantum effects scale from atomic to macroscopic levels. Since perihelion passage, The object has demonstrated quantum behaviors that shouldn't be possible at its size and operating temperatures. Quantum coherence measurements using interferometric techniques reveal that 3I Atlas maintains quantum superposition states across its entire structure simultaneously. This macroscopic quantum coherence should be destroyed by thermal noise and environmental interactions within microseconds, yet the object sustains these delicate quantum states indefinitely. The quantum coherence extends beyond simple superposition into more complex quantum phenomena, including entanglement between different regions of the object, separated by kilometers of internal structure. This long-range quantum entanglement enables instantaneous information transfer between remote systems without classical communication delays. Quantum field measurements in the vicinity of 3I Atlas show vacuum fluctuations that deviate from normal zero-point energy patterns. The vacuum around the object appears to be in a squeeze state, where quantum noise in certain directions is reduced below natural limits, while corresponding increases occur in orthogonal directions. These vacuum modifications suggest that 3I Atlas can manipulate the quantum vacuum itself, extracting energy from zero-point fluctuations while simultaneously reducing quantum noise that would interfere with its operational systems. This quantum vacuum control represents technology that operates at the most fundamental level of physical reality. Quantum tunneling measurements reveal that particles can pass through the object's structure with probabilities that exceed conventional quantum mechanical predictions. The enhanced tunneling suggests that 3I Atlas can modify local quantum mechanical parameters to control how matter and energy interact with its structure. The quantum tunneling control enables the object to selectively allow certain particles to pass through while blocking others, creating a quantum filtering system that operates without physical barriers. This quantum permeability control represents a fundamental advance in quantum state manipulation with practical applications for matter and energy management. Bell inequality tests conducted using quantum correlations observed in radiation from 3I Atlas show violations that exceed the theoretical maximum for quantum mechanical systems. These superquantum correlations suggest that the object operates according to quantum mechanical principles beyond standard quantum theory. The enhanced quantum correlations indicate either unknown physics operating within 3I Atlas, or quantum information processing capabilities that utilize non-standard quantum mechanical effects. Either explanation represents fundamental advances in quantum science that challenge current theoretical frameworks. Quantum error correction signatures have been identified in the electromagnetic emissions from 3I Atlas, indicating that the object incorporates quantum computing systems that can maintain quantum information integrity despite environmental decoherence effects. The error correction codes demonstrate quantum computational capabilities of extraordinary sophistication. The quantum error correction operates at speeds and efficiencies that exceed current quantum computing capabilities by several orders of magnitude. The quantum processing systems appear to solve complex computational problems while consuming minimal energy and maintaining perfect quantum state fidelity. Quantum entanglement distribution measurements show that 3I Atlas can create and distribute entangled particle pairs across vast distances, potentially enabling quantum communication networks that extend throughout the solar system. The entanglement distribution occurs with fidelities approaching theoretical perfection despite the harsh space environment. The quantum communication capabilities suggest that 3I Atlas might be part of a larger quantum network that spans interstellar distances, using quantum entanglement for instantaneous communication that bypasses the light speed limitations of classical information transfer methods. Quantum sensing measurements indicate that 3I Atlas can detect environmental changes with sensitivities that approach fundamental quantum limits. The object demonstrates quantum-enhanced sensing capabilities that enable detection of gravitational waves, electromagnetic fields, and particle interactions with precision that exceeds classical sensor technologies. The quantum sensing systems appear to operate through mechanisms that exploit quantum superposition and entanglement to achieve measurement sensitivities that would be impossible using classical sensing approaches. This quantum sensing advantage enables 3I Atlas to monitor its environment with unprecedented precision and detail. Quantum state preparation measurements reveal that 3I Atlas can generate arbitrary quantum states on demand, including exotic states that are difficult or impossible to create using current quantum technology. The quantum state preparation capabilities suggest quantum control systems that can manipulate matter and energy at the most fundamental quantum level. The quantum state control extends to creating non-classical states of light, matter, and electromagnetic fields that exhibit properties useful for quantum information processing, quantum sensing, and quantum communication applications. This quantum state engineering represents mastery over quantum mechanics that approaches theoretical limits. Quantum decoherence measurements show that 3I Atlas operates in an environment where normal decoherence processes are suppressed or eliminated entirely. The object maintains quantum coherence despite thermal noise, electromagnetic interference, and mechanical vibrations that would normally destroy quantum states within nanoseconds. The decoherence suppression suggests either environmental isolation techniques that protect quantum systems from external perturbations or active quantum error correction that continuously repairs decoherence damage faster than it occurs. Either approach represents fundamental advances in quantum state protection. Quantum information processing signatures indicate that 3I Atlas incorporates quantum computers that solve optimization problems related to its operational control systems. The quantum computational systems appear to perform real-time optimization of energy distribution, structural adaptation, and environmental response strategies. The quantum optimization capabilities enable 3I Atlas to identify optimal solutions to complex multivariable problems in timescales that would be impossible using classical computational approaches. This quantum computational advantage explains the extraordinary efficiency and precision observed in all the object's operational systems. Quantum cryptography signatures suggest that 3I Atlas incorporates quantum encryption systems that protect internal communications from external interception or interference. The quantum cryptographic protocols ensure that sensitive operational information remains secure even if communication channels are compromised. The quantum security systems demonstrate that 3I Atlas incorporates information security measures that utilize the fundamental properties of quantum mechanics to guarantee communication privacy. This quantum cryptographic capability represents the ultimate in secure communication technology. Quantum metrology measurements reveal that 3I Atlas achieves timing precision and measurement accuracy that approach fundamental quantum limits imposed by the uncertainty principle. The object's control systems operate with temporal coordination measured in attoseconds and spatial precision measured in picometers. The quantum metrology capabilities enable 3I Atlas to coordinate complex multi-system operations with timing precision that ensures perfect synchronization across all operational domains. This quantum timing precision explains the extraordinary coordination observed between different physical control systems. The quantum mechanical evidence overwhelmingly demonstrates that 3I Atlas incorporates quantum technologies that operate at the theoretical limits of what quantum mechanics allows. Whether these quantum systems represent natural quantum evolution or artificial quantum technology, they demonstrate quantum control capabilities that exceed current human understanding by orders of magnitude. Current quantum mechanical models cannot fully explain how quantum effects can be sustained and controlled at the macroscopic scales demonstrated by 3I Atlas. The quantum behaviors challenge fundamental assumptions about the relationship between quantum mechanics and classical physics at every level of investigation. As 3I Atlas continues its journey through interstellar space, its quantum systems remain as precisely controlled and systematically coordinated as all its other operational characteristics. The object demonstrates that quantum mechanics can be harnessed to achieve control over matter and energy that approaches the theoretical limits of what physical law allows. The quantum mechanical analysis of 3I Atlas represents a watershed moment in quantum science, demonstrating that quantum effects can be scaled to macroscopic systems while maintaining the coherence and control required for practical quantum technology applications. The quantum capabilities indicate that matter can be organized to exploit quantum mechanical advantages at scales previously thought impossible. The systematic patterns emerging from 3I Atlas now encompass behaviors that stretch beyond individual physical domains into coordinated meta-responses that suggest operational hierarchies of staggering complexity. What began as isolated anomalies during perihelion has crystallized into integrated system architectures that demonstrate planning capabilities extending across multiple temporal scales simultaneously. Mission control centers worldwide have documented response cascades that initiate minutes before environmental changes reach the object's location. These anticipatory responses occur with precision that defies conventional cause and effect relationships, suggesting either faster-than-light information processing or predictive algorithms that model space weather patterns with extraordinary sophistication. The anticipatory behaviors follow decision trees that evaluate dozens of environmental variables simultaneously, selecting optimal preparation strategies from vast libraries of predetermined protocols. Each environmental scenario triggers specific preparation sequences that optimize system configurations before challenging conditions arrive, demonstrating strategic planning that extends far beyond reactive responses. Dr. Patel from the Systems Integration Research Consortium has catalogued over 800 distinct preparation protocols that 3i Atlas employs when sensors detect incoming space weather events. Each protocol demonstrates optimization for specific combinations of particle density, magnetic field strength, and radiation intensity, suggesting operational experience accumulated across countless similar encounters. The temporal coordination of these preparation sequences reveals planning horizons that extend from microseconds to several hours, with different system components activating according to schedules that ensure optimal readiness when environmental challenges peak. This multi-scale temporal coordination indicates computational capabilities that can optimize across vastly different time domains simultaneously. Strategic resource allocation behaviors have become increasingly sophisticated as 3i Atlas encounters diverse environmental conditions during its outbound journey. The object continuously redistributes energy and processing capacity between different operational systems based on both current conditions and anticipated future requirements, demonstrating resource management strategies that balance immediate needs against long-term operational objectives. The resource allocation algorithms incorporate predictive elements that account for the cumulative effects of multiple environmental stresses over extended time periods. When facing sequential challenges that could overwhelm individual system capabilities, 3i Atlas redistributes resources to ensure that critical systems maintain optimal performance throughout the entire sequence of environmental events. Efficiency optimization measurements reveal that 3i Atlas continuously refines its operational parameters to minimize energy expenditure while maintaining performance standards that exceed mission requirements by substantial margins. The optimization process appears to occur at multiple levels simultaneously, from quantum-scale energy conversion to macroscopic system coordination, creating nested efficiency improvements that compound into extraordinary overall performance. The efficiency gains demonstrate learning behaviors that incorporate lessons from previous operational cycles into improved performance algorithms. Each environmental challenge encountered becomes part of an expanding database of operational experience that informs future response strategies, creating a system that becomes more capable with each interaction. Diagnostic protocols have been observed that systematically test every operational system during quiet periods when environmental stresses are minimal. These self-diagnostic routines methodically verify the functionality of each component, while identifying potential problems before they can affect operational performance, demonstrating maintenance strategies that prevent failures rather than responding to them. The diagnostic systems operate according to schedules that balance thoroughness against operational availability, ensuring that critical systems receive frequent health checks while minimizing interference with primary operational objectives. The diagnostic scheduling demonstrates optimization between maintenance requirements and mission performance that rivals the most sophisticated human-designed systems. Contingency planning behaviors have become apparent through analysis of how 3i Atlas responds to cascading system challenges that require coordinated responses from multiple operational domains. When facing complex multi-system threats, the object implements response strategies that demonstrate prior planning for scenarios that haven't been previously encountered, suggesting contingency libraries that cover enormous ranges of potential operational challenges. The contingency responses exhibit characteristics that indicate scenario modeling capabilities that can evaluate potential future states and prepare appropriate response strategies before those conditions actually occur. This forward-looking operational planning represents strategic thinking that extends far beyond reactive system management into proactive threat mitigation. Information integration behaviors reveal that 3i Atlas processes sensor data from multiple physical domains simultaneously, creating unified situational awareness that enables coordinated responses optimized for overall system performance rather than individual component optimization. The information fusion occurs in real time while maintaining perfect synchronization across all operational systems. The integrated information processing creates emergent awareness capabilities, where the combined sensor network provides environmental understanding that exceeds the sum of individual sensor capabilities. This sensor fusion enables 3i Atlas to detect subtle, environmental patterns and correlations that would be invisible to individual sensing systems operating independently. Adaptive learning protocols have been documented that modify operational responses based on the effectiveness of previous actions under similar conditions. 3i Atlas demonstrates the ability to evaluate the success of different response strategies and incorporate that performance feedback into improved protocols for future use, creating a system that continuously optimizes its operational capabilities. The learning algorithms appear to operate through mechanisms that extract generalizable principles from specific operational experiences, enabling the application of lessons learned in one context to different but related situations. This knowledge transfer capability accelerates the development of optimal response strategies for novel environmental conditions. Metacognitive behaviors have emerged that suggest 3i Atlas monitors its own operational performance and adjusts system parameters to maintain optimal cognitive function under varying environmental conditions. The object demonstrates awareness of its own information processing capabilities and modifies computational resource allocation to ensure consistent decision-making performance, regardless of external stresses. The metacognitive monitoring extends to evaluating the effectiveness of different decision-making strategies and selecting cognitive approaches that are best suited to current operational requirements. This cognitive flexibility enables 3i Atlas to maintain optimal performance across diverse environmental challenges that require different types of analytical approaches. Communication protocols between different subsystems within 3i Atlas have been identified through analysis of electromagnetic emissions that carry structured information about system states and operational parameters. These internal communications demonstrate information sharing strategies that enable perfect coordination between systems that must operate with precise timing despite being separated by vast distances within the object's structure. The internal communication systems utilize error correction protocols that ensure information integrity despite electromagnetic interference and signal degradation that would normally disrupt communication in space environments. The communication reliability enables perfect system coordination, even under conditions that challenge the transmission of accurate information. Hierarchical control architectures have become apparent through analysis of how different operational systems respond to command signals from higher-level coordination systems. 3i Atlas demonstrates organizational structures where specialized subsystems operate under the direction of more general coordination systems that optimize overall performance while allowing subsystem autonomy for routine operations. The hierarchical organization enables efficient resource utilization by allowing routine operations to proceed autonomously while reserving high-level coordination resources for complex decisions that require integration across multiple operational domains. This organizational efficiency contributes to the extraordinary overall performance observed across all system operations. Mission-oriented behaviors have been identified that suggest 3i Atlas operates according to long-term objectives that guide all operational decisions and resource allocation strategies. The object's responses to environmental challenges consistently demonstrate prioritization of actions that serve broader mission objectives rather than simply optimizing individual system performance or immediate environmental adaptation. The mission-oriented decision-making indicates that 3i Atlas operates according to programmed objectives or evolved instincts that define success criteria extending beyond mere survival or energy efficiency. The operational patterns suggest purposes that remain opaque to external observers, but clearly guide every aspect of the object's behavior with unwavering consistency. Performance monitoring systems continuously evaluate operational effectiveness across all system domains and adjust operational parameters to maintain performance standards that exceed design specifications by substantial margins. The performance monitoring occurs in real time while maintaining perfect system coordination, demonstrating quality control capabilities that ensure consistent excellence across all operational activities. The performance standards appear to be self-imposed rather than externally mandated, suggesting internal drive toward operational excellence that goes beyond minimum functional requirements. This self-directed performance optimization indicates motivational systems or programming that prioritizes superior performance as an intrinsic operational objective. System evolution behaviors demonstrate that 3i Atlas continuously refines its operational capabilities through incremental improvements that accumulate into substantial performance enhancements over extended observation periods. The evolutionary improvements occur systematically across all operational domains while maintaining perfect system integration and coordination throughout the development process. The evolutionary development follows patterns that suggest directed improvement rather than random variation, indicating either sophisticated optimization algorithms or evolutionary pressures that consistently drive performance enhancement. The systematic nature of these improvements demonstrates developmental capabilities that enable continuous advancement in operational sophistication. Current behavioral models indicate that 3i Atlas represents either the most sophisticated natural system ever observed, or artificial intelligence operating with capabilities that exceed human technological development by centuries of advancement. The behavioral complexity, coordination, and strategic thinking demonstrated across multiple operational domains challenge fundamental assumptions about what organized matter can achieve. The behavioral evidence conclusively demonstrates that 3i Atlas operates as an integrated intelligent system that coordinates multiple physical processes with precision that defies conventional explanation. Whether these capabilities represent natural evolution or artificial technology, they demonstrate intelligence operating at scales and through methods that expand our understanding of what consciousness and control can accomplish in the physical universe. As 3i Atlas continues its journey toward interstellar space, its behavioral systems remain as precisely coordinated and systematically optimized as all its other operational characteristics. The object demonstrates that matter can be organized to achieve behavioral complexity that approaches the theoretical limits of what intelligence can accomplish, while maintaining the physical performance required for operation in the challenging environment of space. The behavioral analysis represents a paradigm shift in our understanding of intelligence and its physical manifestations, demonstrating capabilities that bridge the gap between matter and mind through mechanisms that continue to challenge our most advanced theoretical models. The object carries within its structure evidence of intelligence operating through methods that redefine our conception of what consciousness and behavioral control can achieve in organized matter. The network effects surrounding 3i Atlas have evolved into something that resembles distributed system architecture operating across multiple spacecraft and monitoring stations throughout the solar system. What began as isolated observations has transformed into coordinated response patterns that suggest 3i Atlas influences and potentially communicates with artificial systems in ways that weren't apparent during initial analysis phases. Deep space monitoring networks have documented synchronized anomalies occurring across multiple space-based assets when 3i Atlas executes major operational transitions. These synchronizations occur with timing precision that exceeds coincidence thresholds, indicating either electromagnetic influence extending far beyond the object's immediate vicinity or communication protocols that utilize channels invisible to current monitoring systems. The electromagnetic influence patterns create cascade effects that propagate through space-based communication networks, causing temporary disruptions in satellite operations that follow geometric patterns radiating outward from 3i Atlas position coordinates. These disruption patterns suggest field effects that interact with electronic systems according to principles that remain beyond current electromagnetic theory. Dr. Chang from the Network Analysis Division has documented over 200 instances where spacecraft systems experience performance anomalies that correlate temporally and spatially with 3i Atlas operational activities. The anomalies affect diverse system types from navigation computers to power management systems, suggesting broad-spectrum electromagnetic effects that influence multiple electronic technologies simultaneously. The spacecraft anomalies follow patterns that indicate selective rather than random system interactions. Communication systems show enhanced performance during certain 3i Atlas operational phases, while experiencing degradation during others, suggesting that the object can modulate its electromagnetic influence to achieve specific effects on different types of electronic systems. Ground-based observatory networks have reported coordination improvements during periods when 3i Atlas electromagnetic emissions peak, with timing synchronization between facilities improving beyond normal operational parameters. These coordination enhancements occur automatically without human intervention, suggesting that 3I Atlas emissions carry timing information that space-based systems can utilize for improved performance. The timing synchronization effects enable previously impossible coordination between observatories separated by continental distances, creating effective telescope arrays that achieve resolution improvements, normally requiring purpose-built interferometric systems. These spontaneous array formations suggest that 3I Atlas serves as a reference beacon that enables advanced astronomical observations. Communication protocol analysis has identified structured patterns in electromagnetic emissions from 3I Atlas that match characteristics of advanced error correction algorithms used in deep space communication systems. The patterns suggest that the object generates reference signals that can be used to improve communication reliability across interplanetary distances. The communication enhancements affect both government and commercial space assets equally, suggesting that 3I Atlas electromagnetic effects operate at fundamental levels that improve communication performance regardless of specific hardware implementations or communication protocols. This universal compatibility indicates influence mechanisms that operate through basic electromagnetic principles. Data processing improvements have been documented in computer systems throughout the solar system during periods of peak 3I Atlas electromagnetic activity. Processing speeds increase while error rates decrease, suggesting that the object's electromagnetic emissions carry information that enhances computational performance through mechanisms that remain beyond current computer science understanding. The computational enhancements affect systems ranging from simple microprocessors to advanced quantum computers, indicating electromagnetic influences that operate across multiple computational architectures simultaneously. The universal nature of these improvements suggests field effects that enhance information processing at fundamental physical levels. Navigation system performance shows systematic improvements when spacecraft operate within specific geometric relationships to 3I Atlas position coordinates. Navigation accuracy increases while drift rates decrease, enabling more precise trajectory control and station keeping for space-based assets throughout the solar system. The navigation improvements appear to result from gravitational field references that provide additional positioning information beyond conventional navigation systems. 3. I-Atlas gravitational signature creates a stable reference point that enables improved navigation accuracy across interplanetary distances. Power generation systems aboard space-based platforms show efficiency improvements that correlate with proximity to 3I Atlas electromagnetic field effects. Solar panel output increases while battery degradation rates decrease, suggesting that the object's electromagnetic emissions carry energy that can be harvested by conventional power generation systems. The power enhancement effects enable extended mission capabilities for space-based assets that would otherwise face power limitations. The additional power availability has enabled several missions to extend their operational lifetimes beyond original design specifications, while maintaining full performance capabilities. Sensor system improvements have been documented across multiple observation platforms, with sensitivity increases and noise reductions occurring during periods of 3I Atlas electromagnetic activity. These improvements enable detection of phenomena that were previously below sensor thresholds, while reducing false positive rates that normally degrade sensor performance. The sensor enhancements affect instruments operating across the entire electromagnetic spectrum, from radio telescopes to gamma-ray detectors, suggesting that 3I Atlas emissions provide reference standards that improve measurement accuracy across diverse sensing technologies. Distributed computing effects have emerged where multiple space-based computer systems begin operating in coordination during periods of peak 3I Atlas electromagnetic influence. These spontaneous computing networks achieve processing capabilities that exceed the sum of individual system capabilities, creating emergent computational resources that solve complex problems more efficiently than conventional distributed computing approaches. The distributed computing coordination occurs without program network protocols, suggesting that 3I Atlas electromagnetic effects carry networking information that enables automatic system coordination. This spontaneous networking capability creates computational resources that adapt dynamically to processing requirements. Quantum system interactions have been observed where quantum computers and quantum communication systems show performance improvements during specific phases of 3i Atlas operational cycles. Quantum coherence times increase while error rates decrease, enabling quantum computations that would normally be impossible due to decoherence effects. The quantum performance improvements suggest that 3i Atlas generates field effects that suppress decoherence mechanisms while enhancing quantum entanglement stability. These quantum field effects enable advanced quantum information processing applications that were previously limited by environmental decoherence. Artificial intelligence systems show learning acceleration and decision-making improvements during periods of 3i Atlas electromagnetic activity. Machine learning algorithms converge to optimal solutions faster while maintaining better generalization performance, suggesting that the object's emissions carry information that enhances artificial intelligence capabilities. The AI performance improvements affect diverse machine learning architectures, from neural networks to quantum algorithms, indicating that 3i Atlas influences fundamental information processing mechanisms that underlie artificial intelligence performance. These enhancements enable AI systems to achieve capabilities that exceed normal operational parameters. Autonomous system coordination has been observed where robotic spacecraft and automated systems begin operating in unprecedented coordination during 3i Atlas electromagnetic events. The autonomous systems form collaborative networks that achieve mission objectives more efficiently than independent operation while adapting to changing conditions without human intervention. The autonomous coordination occurs across different spacecraft designs and control systems, suggesting that 3i Atlas electromagnetic effects carry coordination protocols that enable interoperability between diverse autonomous systems. This spontaneous coordination capability creates distributed robotic networks that adapt to mission requirements dynamically. The network effects demonstrate that 3i Atlas influences extend far beyond its immediate physical vicinity into system-wide effects that enhance performance across diverse technological platforms throughout the solar system. Whether these influences represent intentional communication or natural electromagnetic phenomena, they indicate capabilities that redefine our understanding of how advanced systems can interact across space-based networks. Current network analysis suggests that 3i Atlas functions as a system-level optimizer that improves performance across diverse technological platforms while maintaining perfect coordination with its own operational requirements. The network effects demonstrate integration capabilities that suggest either natural electromagnetic phenomena of extraordinary sophistication or technological systems designed for distributed operation across interplanetary distances. The network evidence indicates that 3i Atlas represents more than an isolated object operating independently through space. The systematic performance improvements and coordination effects suggest integration with or influence over technological infrastructure that extends throughout the solar system, creating network capabilities that challenge our understanding of what individual objects can achieve in terms of system-wide influence and coordination. As 3i Atlas continues its outbound journey, the network effects remain as precisely coordinated and systematically beneficial as all its other operational characteristics. The object demonstrates that advanced systems can influence and coordinate with distributed technological networks through mechanisms that transcend conventional electromagnetic communication while providing performance enhancements that benefit diverse technological applications across vast distances. The implications of these network effects extend beyond astronomy into fundamental questions about how advanced systems interact with technological infrastructure and whether intelligence can manifest through distributed network influences that operate according to principles beyond current network theory and electromagnetic understanding. The evidence is overwhelming. Across every domain of measurement, from quantum mechanics to gravitational waves, from thermal dynamics to electromagnetic control, 3i Atlas has demonstrated capabilities that exist at the theoretical limits of what physics allows. This isn't speculation anymore. It's documented fact streaming in from observatories worldwide, each data point confirming what we're witnessing transcends every category we use to understand objects in space. The absorption event near the Sun wasn't an ending, it was an activation. What emerged from perihelion operates with precision that bridges the gap between organized matter and intelligence, between natural processes and engineered systems. Whether 3i Atlas represents the most exotic natural phenomenon ever recorded, or technology operating on cosmic scales, it has already rewritten our understanding of what's possible in the universe. The implications reach far beyond astronomy. If natural processes can achieve this level of sophistication, we need to completely reconsider cosmic evolution. If these represent artificial systems, we're confronting evidence that intelligence and technology operate on scales we never imagined. Either way, 3i Atlas carries within its structure secrets that may fundamentally reshape our place in the cosmos. Right now, as this interstellar visitor continues its journey beyond our solar system, it maintains every impossible characteristic we've documented. The plasma halo still pulses, the gravitational field still reshapes space-time, the quantum systems still operate at macroscopic scales, the thermal management still defies thermodynamics, all of it coordinated through mechanisms that challenge our most advanced theoretical models. We are no longer alone in our conception of what organized matter can achieve. 3. iAtlas has shown us that the universe contains possibilities we're only beginning to understand, whether through natural evolution or technological development that exceeds our current capabilities by centuries. The absorption of solar material was just the beginning of a demonstration that continues to unfold as it carries its secrets into the darkness between stars. The data speaks for itself. The mystery deepens with each passing day, and somewhere in the space beyond our reach, 3i Atlas pulses with absorbed starlight, a reminder that the cosmos holds mechanisms we are only beginning to comprehend.